away at break of day to find a forgotten gold. I don't know how much you hear the music's a banger. Um, okay, I think we were doing Magic Squares. Something like okay, I'm making this side a little bit bigger. Like that's the max. Oh wait, yeah. So we're just starting off where we left off. We're doing a square. Nothing too complicated here. Um. Oh, you can't see the textbook now. It's kind of weird. There. Oh, there. So we create is magic function. I think we've done this before. I've done this before, so I just copied the code from there. Um. So and also we shouldn't instead of we're iterating over this while it's being adjusted, which isn't too good. So the better way to do it is instead of doing this, we should say in current digits, not in, or we just leave it blank for this one. And then we remove this call. That's fine. Alright, yeah, remove these. I can't believe I just forgot that we can't. I don't know why I started iterating over something. That's not the proper way to do it. I knew that, but I guess we just did it anyway. Um, this is like probably not the most efficient way to test this. This is also gonna be extremely slow. Ooh, yeah, I can already think about the Think about all the stuff that's gonna be testing. This is a slight. Wait. Oh, it's all different, unfortunately. Paste my memory. I've done something pretty similar. That's why I already had this code on hand. Which would be nice. But I think it's not fully robust. You need to check if the numbers are repeated. But we can do that in a little bit. Oh, we need to change the definition because being used force defined. No, there's nothing there. Cool. Uh, uh, move these gaps. Those be rather confusing. This is very, very ugly code, right? Because you don't want to be doing for loops like this. Maybe you could use something with editor tools or something. I think that would be one way to speed this up. Another way would be to just make it. I'm sure there's so many optimizations you can make for this, which is why this is a pretty fun thing to be. Oh, oops. This is supposed to be X6. Two. Oh, that was supposed to be there. Oh, I'm going to change these into if statements. So, huh. So if I print, so if I create, if I have a, oh, apparently we covered this wrong last time. Okay, it's wonderful, 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 wonderful. Okay, yeah. So obviously the way would be to do this. Then how do we? Oh wait, this is pretty easy. You just do sum square 0, sum square 1, sum square 2, right? That tests this 0, 1, 2. Then you have to test the other side, so you have to do sum square um um oh, we have to use list comprehension here. For row in a square, we have to do square dot 0. Or no, it should be row dot 0. Oh, and then we have to check both diagonals. This is unfun. Now we have to check the diagonals. How would we go about doing this? Pretty simple. Um, so for row in square, this accesses all the row, and now for uh I in range len oops uh I leave all these gaps. I don't know how I just do this, but uh so I'm just gonna put 3. Oh, yeah, actually, there's a better way to do this. Instead of doing this, we should just iterate over the length of the array. So we should do for I in range, right, len square, right? Then we can do, to access the row, we can do square dot I, right? This will access all the rows. But then what we need to do is we need to access the ith index. So for the first one, we do the I, ith index 0, 1, 1, 2, 2, 3, 3, and then we sum those. And then the opposite applies here. So let's just copy this code in. But here, let's do 3 minus it. It's a pretty fun condition. I apparently wrote this code when I was like on crack or something because very bad. So what we have to do instead of this, we do 3 minus I. So that way, the first one will be, sorry, 2 minus I. It should be 2 minus I. Just do the max index. Right, so the first one will be 2, second one will be 1, last one will be 0. Boom. Pretty cool. And then just add a quick parentheses. We don't know why we deleted that. Returning the and all of them. Well, let's just check this actually work. 8, 16, 14, yeah. 8, 3, 4. Yeah, this is like pretty reasonably fast actually. What Skycak says is that whatever. Ooh, this is a fun Newton's method. Dude, I remember when I was a little bit in India last year, someone was like, we had a test and we had to find the root of a pretty easy function. It was a pretty reasonable function, and someone used Newton's method to do it. I don't even know why they used Newton's method, but they used Newton's method. They were a pretty fun person. They used Newton's method to do it, which is a pretty unusual way to do stuff like that. Hey, do you go to school? No, my school only starts. What? My school only starts at